So now let's have a discussion about heat transfer. Now say suppose you are holding a metallic rod. You are holding a metallic rod and you are supplying heat over here. Now actually the physical process that takes place is because in metals there are free electrons. There are free electrons. So these free electrons conduct energy. So it helps in conduction. So because it's a metal, the amount of heat energy that is produced in here or given in here will be transferred to different positions of the rod. Now, if we are holding this rod over here, so we will feel the heat energy. Now, why is this so? The physical phenomena that is related for the conduction is because of the free electrons. And because of this free electrons, they transfer energy. Now, we have often seen or heard that metals are used for conduction of electricity. Now, what electricity is also a form of energy. So, this is done because of the free electrons. So, therefore, we can say that heat energy is conducted. That is, a conduction is taking place. So, what is conduction? Now the question is, what actually is conduction? So if you want to define conduction, you can define this. Conduction is a mechanism. Conduction is actually a mechanism in which heat is transferred from one point to another. So this is what you can understand by the word conduction. Now this heat conduction may be described quantitatively as the rate time of heat flow in a material for a given temperature difference. Now we know that for different substances you have different amount of heat that you feel at different interval of time. So heat conduction for a particular substance, it can be defined as a quantitatively as the time rate of heat flow in a material. Now, if you are applying a heat, so the time rate, that is how much time does it take to transfer this much amount of heat to this position for a given length. Now for a given length, what is the transfer of heat energy in a given amount of time? Therefore, we can say that it is also giving a measure of rate. This is a rate. So now, with this particular question that we ask ourselves, and by understanding the basic concept of conduction, we come to conductivity, that is thermal conductivity. Thermal conductivity. Now we know that thermal conductivity depends upon the cross-sectional area, that is how big is the cross-sectional area. This is known as cross-sectional area. This is known as length. Plus we also have the K, that is thermal conductivity, that is how much can this particular substance conduct heat energy, that is known as K. So you have a relation. Now plus also you have, say suppose over here at this point you apply a temperature T final, and in this you apply T initial. So the difference in temperature, say suppose this is the temperature now and this is the initial temperature. So this is a difference in temperature. What is the difference in temperature over here to that over here? So all these factors will give you the relation for thermal conductivity. And the relation for thermal conductivity is given as such. the heat flow H is equal to K, which is the constant for proportionality of thermal conductivity. This is a constant for proportionality of thermal conductivity, K, into area of cross section. That is, the bigger the area of cross section, the more heat will be transferred, into the difference in temperature, that is T final minus T initial, or you can say TA minus TB, depending. So the difference in temperature where the heat is being supplied divided by the length. Now when the length increases, the heat flow decreases, but when the cross sectional area increases, the heat increases, and when there is a huge difference in temperature, then also heat increases. So this is the rate of heat flow in a particular material, which we have derived from our concept of thermal conductivity.